So we're going to look at the quadratic formula, and before we do that, let's review why we're going to use it. So when we use quadratic formula, that helps us solve a quadratic equation, and your quadratic equation is of the form ax squared plus bx plus c. And so your a, b, and c are all values, and in order to solve, it does need to be equal to 0. And so once you've got that, you're going to plug those coefficients, or the constant, so a, b, or c, into a formula. And this formula is derived from the distance formula. And so hopefully you've seen that derived before, but if not, this is the formula. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And so what's really nifty about the quadratic formula is this radicand under here, this b squared minus 4ac, is called the discriminant. And it tells us how many zeros we're going to end up with, how many roots we're going to end up with, and what kind. So are they going to be real? Are they going to be imaginary? Is there going to be 1? Is there going to be 2? And so first thing you need to ask yourself, is the discriminant positive or negative? If it's positive, you then need to ask yourself, is it a perfect square? And if you can answer yes to both of those, then you're going to have 2 real rational solutions. If it's positive and not a perfect square, then you're going to have 2 real irrational. And that just means this is going to be a decimal, the irrational, and the rational is going to be a whole number. If it's negative, then you get 2 imaginary roots. And then you really have one other option. If your discriminant equals 0, then you have 1 real rational. So you've got a couple of different options there. You could end up with 2 real rational. I don't know why my pens aren't working. You could have 2 real rational solutions. You could have 2 real irrational. You could have 2 imaginary, or just 1 irrational, or 1 rational, sorry. And so that'll come in handy. It's just a good way to check. And so now we'll look at an example using that formula. I'll try to leave them both on the screen. And so your first example is 3x squared equals 9 plus 6x. And if you remember, in order to use the quadratic formula, your equation has to be equal to 0. So we're going to move this 9 and this 6x over, combine like terms if we've got any, and we're going to rewrite in descending order. Make sure it's equal to 0. And then we're going to identify our a value, our b value, and our c value. When we plug into the formula, you should only have numbers. You should not have any x's other than your x equals. So we're going to have x equals a negative b. So a negative 6 is a positive 6. Plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is negative 9, all over 2 times a, which is 3. And so we're just going to simplify that. And so we're going to simplify it first by solving what's underneath that square root. We're going to solve for the discriminant first. And so you can plug that straight into your calculator. And what you should find is 144. So be careful with your parentheses. Be careful with your minuses or your negatives. So I'll have 6 plus or minus the square root of 144 all over 6. And so if we pause there, what we can find, if the discriminant is 144, we see that it's positive. We see that it's a perfect square. So in the end, we should have 2 real rational roots. root solution, x-intercepts, however you want to call it. And then we'll just keep solving, so we'll have x equals 6 plus or minus 12 all over 6. And since we're going to get two roots, we want to add 12, and we want to subtract 12. So we'll have 6 plus 12 is 18 divided by 6 is 3. 6 minus 12 is negative 6 divided by 6 is negative 1. So you have a solution set of negative 1, 3. You can write it using these fancy brackets or as x-intercepts. But those are your two solutions. So we'll look at another example. Bring it down here. And so the second example I want to look at is x squared equals 7x minus 19. In order to solve using quadratic formula, it has to be equal to 0. So we're going to move our 7x and 19 over. Do that with your opposite sign so that it cancels. And then here, we're going to identify our a, b, and c. So in front of this x squared, there's technically not a coefficient that we can see, but we know that there's a 1 there. So we know that a is going to be 1, b will be negative 7, and c is going to be 19. Can't really see that green though, can you? And so then we're going to plug it into the formula. So we're going to have our x equals, remember there's going to be no other x's, everything else should be a number. A negative b, so negative 7 is a positive 7, plus or minus the square root of negative 7 squared, minus 4 times a, which is 1, and c, which is 19, all over 2 times a, so all over 2 times 1. And we're going to find that discriminant first, so we'll plug that straight into our calculator, that negative 7 squared minus 4 times 1 times 19. And what we end up getting is a negative 27 divided by 2. And so based off of that discriminant, since it is negative, since my discriminant is negative, we're going to have two imaginary roots. And then we're just going to simplify. So over off to the side, I'm going to simplify this negative 27. And so first things first, I'll take care of that negative. So square root of negative 1 times the square root of 27. So then I'll have I times the square root of 27. The biggest perfect square factor for 27 is 9. 9 times 3 gives me 27. And so this actually reduces all the way down to 3i root 3. So over here, when we simplify it, I'm going to have 7 plus or minus 3i root 3 all over 2. And that is my solution set. So that means that it doesn't cross the x-axis, but it technically does have those imaginary solutions. All right, we'll look at two more examples. So we've got a 9x squared plus 64 equals 48x. We want it equal to 0 and in descending order, so we're going to subtract 48x from both sides. It is now equal to 0, which means that we can identify our a value, our b value, and our c value. And once you've done that, you can plug it directly into the quadratic formula. So remember, you're only plugging in numbers. You shouldn't have any extra x's hanging out somewhere. So we'll have a negative b, so positive 48. And then underneath the radical, we'll have our b squared, so negative 48 squared minus 4 times a, which is 9, times c, which is 64. That seems like it's going to be a really big number. all over 2 times a. So we'll go ahead and find that discriminant. So what is underneath that radical? So negative 48 squared minus 4 times 9 times 64. It seems like it's going to be really, really big, but then when we plug it in, we get 0. So when my discriminant is 0, if we flip back to this chart, we're going to get one real rational solution. Or root, or 0, or x-intercept, however you want to say it. And it's all over 18. So then we've got the square root of 0, and the square root of 0 is just 0. And so what happens when we add or subtract 0 from 48, it just gives us 48. So that just stays as 48 on the numerator, and then we've got 48 over 18. If we can reduce it, we do want to. So 48 and 18 are both divisible by 6. So we're left with an 8/3. And so that just means your parabola on the graph is going to touch the x-axis. It's not going to cross it, but it's going to touch it at 8/3. So you can write it using the fancy brackets or as the x-intercept. Last example we're going to do for quadratic formula. 2x squared plus x equals 5 minus 3x. In order to use the formula, we do have to set it equal to 0. So I would encourage you to maybe pause the video right now and see if you can solve it. See how far you can get by yourself. So I'm going to subtract 5, add 3x to both sides. What's interesting about this one is now we have some like terms in that x and 3x. So when you write it in descending order, make sure you've got those combined. Once it's equal to 0, we can find our a value, our b value, and c value. And so we're ready to plug it into the formula. Remember, when you plug it into the formula, it's only numbers, no more x's. So we're going to have a negative b, so a negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 2, times c, which is negative 5. All over 2 times a, which is 2. And to make solving easy, we're going to find that discriminant first. So I have 4 squared minus 4 times 2 times negative 5, and you should get a 56. 56. All over 4. And so if we look back at our chart, it is positive. It is not a perfect square, so we have 2 real irrational roots, which means we're going to get some decimals in the end if we plug it in the right way. So 2 real irrational. So we'll keep going off to the side. I'm going to go ahead and simplify my square root of 56. The biggest perfect square factor is 4. And then square root of 4 is 2 root 14. So over here, I'm going to have a negative 4 plus or minus 2 square roots of 14 all over 4. And so what you'll notice here is actually your negative 4, your 2, and your 4, so your coefficients, if you will, all have a common factor of 2. So we're going to divide a 2 out. And so when we do that, we get a negative 2 plus or minus square root of 14 over 4. Now, this simplifying doesn't matter so much if you're just going to get decimals in the very, very end. It'll give you the same value. But if I do ask for the simplified exact, you do have to reduce it all the way. So those are your 2 solutions. You get the 2 because you add the square root of 14 and subtract it. And so there you go.